Have you ever stopped to wonder how your favorite app just knows you? Or how your online shopping cart remembers that thing you added like an hour ago? Well, today, we're going to pull back the curtain and decode the invisible language that makes all of that magic happen. It's called SQL.
Seriously, think about it. It's something we interact with every single day. From your social media feed that seems to read your mind, to your banking app that shows your exact balance. How does it all just work so seamlessly?
Well, all that information, your username, your likes, your purchase history, you name it, it's all stored away in what you can think of as a giant, perfectly organized digital filing cabinet. The technical term for this is a database.
But here's the thing. You can't just walk up to this digital cabinet and start pulling out files. You need to know how to ask for them properly. You have to speak its language. And that very special language is SQL.
All right, so let's dive in. What exactly is this powerful language? SQL actually stands for Structured Query Language, and it's pretty much the universal way we communicate with the databases that power almost every single app and website you use.
At its heart, SQL is like the ultimate translator between you and the database. It's what lets you ask it questions, give it new information, or tell it to change something it already knows.
Now, here's what makes SQL so cool and so different. It's how it works. It's fundamentally different from most programming languages you might have heard of, and honestly, this is its secret superpower. Okay, check this out. With most languages, you have to write a super detailed, step-by-step recipe for the computer to follow. But with SQL, you just tell the database what you want. You just say, hey, get me the names of all the students in grade 10. You focus on the what, and the database itself is smart enough to figure out the fastest, most efficient how. It's like the difference between giving someone turn-by-turn directions versus just saying, take me to the library. It's a game changer.
But hold on, before we can ask for any data, we need a place to put it. We have to build our digital filing cabinet first. And in the world of SQL, that cabinet is called a table.
To build that structure, we use our very first command, create table. Just think of this as drawing up the blueprint for our table. We're defining exactly what it's going to look like.
And the structure is actually pretty simple and logical. You just start by saying, create table, and give your table a name. Then, inside these parentheses, you list out each column you want, like name or age, and you tell SQL what kind of data is going to go in there.
Let's just start with two of the most common data types you'll ever use. Text is, you guessed it, for storing text, things like names or descriptions. And integer is for whole numbers, like an ID number or maybe a class number.
So putting all of that together, here's what it looks like in the real world. We're creating a table called students, and it has 4 columns: name, which is text, class and roll, which are numbers, and section, which is also text. And boom, with just the simple command, we've built our very first totally empty container for data.
Okay, so an empty table isn't very useful, is it? Now it's time to actually put some information inside. This is where we start manipulating the data.
To add a new record, like a new student in our case, we're going to use the insert into command. This is how we start to populate our table one row at a time.
And the command almost reads like a plain English sentence. We tell the database to insert into our students table, we list the columns we want to fill, and then we provide the values for those columns in the exact same order. And just like that, our student Rakib is now officially in our database.
But, data is rarely static. It changes all the time. People move, details get corrected. For that, SQL gives us the update command, which lets us modify records that are already there.
Now this is where SQL gets really precise. We tell it to update the students table. Then we set the section column to B. But here is the most important part of this whole command, the where clause. This tells the database to only make that change on the row where the name is Rakib. Seriously, if you forget that line, you might accidentally change the section for every single student in the entire table.
Okay, so we've built a structure and we've put some data into it. Now we get to the really exciting part, getting answers out of it. This is where SQL got its middle name, query.
The select statement is truly the heart and soul of SQL. It's the command you're going to use more than any other, and it's all about asking your database questions to find exactly what you're looking for. The simplest query you can write is select star. That little asterisk, the star, is a wildcard that just means all columns. So this command is literally telling the database, select all the columns from the students table. It's the quickest way to just see everything you've got.
Seeing everything is useful sometimes,
but let's be real, it's rarely what you actually need. The real magic of a database is its ability to find that one specific needle in a giant haystack.
And this is exactly how we do it. Instead of that star, we specify the exact columns we want to see, name and role. Then, just like with our update command, we use that super important where clause to filter the rows. So this command is asking, show me just the name and roll number, but only for the students who are in class 10.
You know, our needs are always changing. So what happens when you realize you forgot to track a really important piece of information when you first designed your table? Do you have to delete everything and start over?
No way! SQL is designed to be flexible. We can use the alter table command to modify an existing table structure on the fly. So here, we're adding a brand new column called marks to our students table, and we're not going to lose a single piece of the data we already have.
So there you have it. We've gone from building a container for data to filling it up and changing it, and most importantly, to asking it questions. These are the absolute fundamental building blocks of the language that's spoken by nearly every database on the planet. You now hold the key. The only question left is, what secrets will you unlock?